Okay, so hi everyone, good evening, and today we are going to start with the next part from the statistics, second day for the statistics. That is a different charts or graphs, we can say, how we can represent the data that we need to understand today. Okay, so simply it is given as a bar chart over here, and one pie chart is given. Generally, there are number of charts. You can represent your data with a column chart, with a bar chart, with a scatter plot, with a line chart or line plot, pie chart. So pie chart is just like what we can say, circular representation, and each category is given with the sector over here. You can call it as a sector, like some part of the circle. And based on the like degrees, suppose 360 is divided by that particular proportion, and we can like in percentage it is divided 45 degree, 108 degree, 81 degree. So overall it will be a 360-degree. Suppose categories are there, red, green, blue, and you are getting the number of students for that. So count you can get on the y-axis. Different representations are there according to the like category, according to the nature of a data. We can go for it. Okay, suppose I am having 5 to 8 categories, so this is suitable. Pie chart is a suitable. So we can take a call which graph we should use, or which graph is giving the more insights for us, right? So these are the things that we will do. For this, we will use two libraries from the Python. One is a Seaborn, okay, and second one is a matplotlib. Matplotlib. These two libraries we will use for the visualization purpose. By the time or in upcoming sessions for the data visualization, we will use the Power BI for the same. So Power BI is like separate tool or software where we will go with these visuals again. But as of now, in Python, these two libraries are provided. There is Seaborn and Matplotlib, right? So suppose histogram is there, simple, which will give you the range. Suppose how many values are there in the range of 300 to 400. This is giving you the break, or you are breaking that axis in order to start somewhere. It is not starting from 0 and 0, 100, 200 like that. So if we want to start somewhere in between, so we can use that sign, that is a breaking, as it is starting from 0, 10, so 30, 40 like that. So number of lamps. So that area is giving you how many values are there in the range of 400 to 500. For that, what we prepare actually, we prepare a frequency table, right? What is the range between 300 to 400? What is the count? Suppose 15 values are there. In 400 to 500, in this range, 55 values are there, 58 values are there, like that. If you are plotting the line graph, simple line chart or a simple line graph, then suppose two different values are there. One is actual one, okay. One graph is like one is actual one is a predicted one, okay. Suppose this is a January sale, February sale, and March, April, this way, okay. And these are the like sale values. On y-axis there is a sale. Actual sale was like this. Actual sale is supposed like this, and prediction given by the model like this. So if you want to compare these two values, what is the prediction, what is the like actual values, we can use this one, right? Line graph. So according to our use case, according to our need, we can go for it, right? Again, box plot is there, scatter plot is there. So first of all, we'll try to understand this scatter plot. So scatter plot is nothing but it is checking the like, it is giving you the spread of the values. Suppose you are taken into the consideration two different variables. Okay, am I audible? Sharanya, is it going good?
Yes, sir.
Okay.
Yes, sir.
So, in scatter plot, you will just get the distribution, how values are spread. It is not giving, like always, it is not useful. Like, frankly speaking, most of the time it is giving you the like very messy nature. We are not getting a proper insight from it. So we need to understand the data more on other plots. We need to use the other plots as well in order to understand the data. But if you want to see the nature, spread nature, how data is spread, right? Yesterday we have discussed the things related to spread, related to dispersion. What is the mean? What is the dispersion? What is the range? right? Variance, how data variability is there. So that can be understood by the help of scatter plot. This is very important. Box plot. Okay. So it will give you the visual representation for the outliers. There is one term which is called as the outliers. Simply you need to understand what is mean by outlier. So outlier is nothing but the observations, those are away from a given range. Suppose 1, 2, 3, 4, 5 is there, and there is one observation that is 100, another is a 105. So obviously these two are the away from this given range. Most of the observations are around 3, and 100 and 105 that is away from this range. So those observations we call it as an outliers. In order to find out the outlier, we are using one technique that is called as one chart, that is a box plot. So if I'm plotting it based on some data, suppose you are having age values, and for the age values, what you are plotting? You are plotting a box plot. So it will give some thing like this. Suppose 1, 2, 3, 4 lie somewhere here, 1, 2, 3 here, 4, 5 here, and this 100 and 105 lie somewhere here, 100 and 105 like this. So below this lower tail and upper tail, some minimum and maximum range is there. Just try to focus on these values. What is this? Q1. What is this? Q1. What is this? Q3. So yesterday we discussed something like Q1 and Q3, right? Suppose I converted my data into the 4 quarters, right? I will repeat again. This is 50th percentile. Somewhere there is a 0, somewhere there is a 25, then 75 and 100. So you have converted your data into these 4 different quartiles. 1, 2, 3, 4. So this 25 is a Q1, this is Q2, and this is Q3. Is it fine till now? Q1 and Q3. Q1 that is a 25th percentile, Q3 that is a 75th percentile. Anything that is below this point, but how? What was the IQR value? IQR is nothing but IQR is equal to Q3 minus Q1. This was the formula, right? So this range, Q3 minus Q1, that is nothing but IQR, and anything that is below Q1 minus 1.5 times IQR. So suppose for a particular range, 1, 2, 3, 4, 5, 6, 7, 8, 9, I'm having values like this. And for this, if I'm plotting the Q1, Q1 is nothing but 7 for this, and Q3 is suppose 3, or Q1 is 3 and Q3 is 7. After calculation, I'm doing all these things. Suppose I'm getting like this. So IQR will be 4 in this case. IQR will be 4, and this minimum value will be, minimum is equal to, what will be minimum? That is Q1 3 minus 1.5 times IQR. So it will be 3 minus 6. So minus 3. So here minimum will be minus 3. Minimum value will be minus 3. What will be the maximum? Maximum is equal to 3 plus 1.5 times IQR. That is a 4. So 3 plus 6. That is 9. So whatever values for this range 1, 2, 3, 4, 5, those are below minus 3 and above plus 9 will be considered as the outlier. I hope you are getting.
Yes, sir.
Everyone. Bhavya, Prema.
Yes. Yes, sir.
Yes, sir.
Whether there is a need to repeat. If you want to repeat me, I can repeat number of times. But just try to understand. Okay.
The maximum is Q3 minus 1.5 into Q1.
No, Q3 plus 1.5. There is printing.
Okay.
It's a Q3 plus. So whatever values, those are like greater than this and less than this. Minus 3, minus 4 will be less than minus 3. Minus 5 will be less than minus 3. Then 9 plus, suppose 10, 11, 12, those will be considered outliers in this case. Is it okay? Okay.
Yes. Yes.
Next, something it's called as the probability density function. So probability, that is like some possibility to lie in that region, or possibility we can say. And density is nothing but how many values are there in that particular region. Density, that means its occurrence in that particular region. So probability density function is a statistical information or statistical expression, we can say. What is it? Statistical expression that defines the probability distribution, how your values are distributed among, if you plot those values, suppose these dot dots are nothing but data points. These dot dots are nothing but data points, but these are the discrete one. Suppose 10 values are there. 10 values are there. I can call it as a discrete distribution or a discrete scenario is there. If this is like there are 1000 values, so those will be like this, and you can join like this, right? So the nature of a graph is like this. It's a continuous one. If nature of a graph is like this, it is a discrete one. Generally, it will be in the case of categorical variable, 4, 5, 6, 7, 8, 9 categories are there. And this will be in the case of continuous one. If continuous data is there, like you are having salaries of the person, you are having price of the vehicle, okay, you are having suppose experience, different values will be there. And what will be in categorical? You are having yes and no only. You are having grades, good, better, best, like that. You are having blood groups of the person, A, B, AB, O, like this. Is it okay?
Yes, sir.
Discrete values are there and continuous values are there, which are giving you the probability density function. We are not going to calculate anything for the probability density function, just we need to understand the concept. Okay, how probability distributed? Just try to understand from this example. Suppose we have 2 coins, those are unbiased and tossed. So I'm just assuming x is equal to number of heads. How we are calculating x? X is equal to number of heads. That is, x is a random variable. We have seen the types of variable: dependent variable, independent variable, and random variable. That time also we have discussed like random variable will be in case of a dice thrown, right? Then coins are like flipped. That can be called as a random variable. So what x we have as a number of heads. If we are throwing the 2 coins, what will be the sample space? Sample space would be 2 head may be there, 1 head, 1 tail may be there, 1 tail, 1 head may be there, and 2 tails. So total sample space would be 4. Total sample space will be 4. Total sample size will be 4. Output function will be x of hh. Yes, how much it will be? 2 times head is a 2. 1 time head is equal to 1. Again, for third experiment, head is 1. For fourth experiment, head is 0. So this is how it will work. Is it okay? Output
Yes,
of the function, right? And if you want to find out the probability, x of 0, probability that number of heads is a 0, that will be number of heads is a 0 is equal to 0, right? Sorry, number of heads is a 0 is probability of tail is equal to 1 by 2 into 1 by 2, that is a 1 by 4, right? Na? Total will be 1 by 4 only. How much time it is coming? 1 by 4 only. 1 time it is coming. Total sample size is a 4. So it will be 1 by 4. Probability that number of heads is a 1. 2 times it is coming, right? 1 by 2 into 1 by 2 plus 1 by 2 into 1 by 2. So how much it will be? You can simply write 2 by 4. If you don't want to go into this calculation, how much time it is coming? Just 1 head and 1 tail, right? 2 times it is coming. Total sample size is a 2 by 4. It will be 1 by 2. Again, probability that number of heads coming as a 2. Yes, again 1 by 4. 1 time it is coming only. So if you don't want to go to this calculation, you can simply write from here also. 2 times head is occurring 1 time, 1 by 4. No heads are occurring is a 1. That experiment like occurrence is 1 only, 1 by 4. And for this it will be a 2 by 4 only. Overall summation will be 1 by 4 plus 2 by 4 plus 1 by 4 is equal to 1. Overall probability is always 1 only. Yes? Clear?
Yes, sir.
So this is how it is working, probability distribution. Then it comes to the normal probability distribution, that we call it as a Gaussian distribution as well. So different words are there. Normal distribution, ND, Gaussian distribution, sometimes called as the bell-shaped curve. So this shape is nothing but bell shape. It is just forming the shape like a bell. So sometimes it is called as the bell-shaped curve as well. So it's a backbone of a data science. If you want to understand the data, if you want to work on the data in data analytics, in data science, in machine learning, you need to understand the normal distribution very well. Okay. So what is the expectation? Your data should follow the normal distribution. So that is the general expectation. Your data should follow the normal distribution, which was discovered by the Carl Gauss, and so it is called as the Gaussian distribution as well. It is also called as the Gaussian distribution and known as bell curve because it's a bell-shaped graph. Okay, so on y-axis you are having the frequency, on x-axis you are having the values. Why this shape is like this? This shape is like this that because most of the values are lying in this region. Most of the values are in this region. That's why. So if more values are again around the mean, then it shape will be like this. It will go up this way. Is it okay?
Okay, sir.
Right? So in normal distribution, three central tendency measures are there: mean, median, and mode. Okay? Mean, median, and mode are equal. Then we can call it as a normal distribution. Generally, this is not followed. Mode is not satisfying the condition as well always, but mean and median are satisfying that condition. The mean and median is overlapped or it is at same position. Then it's a normal distribution. Distribution is symmetric about a mean, right? So 1, 2, 3, 4, 5. 5 values are there. So mean for this will be a 3. What will be the mean? 3. And this value will be at center. So it will be like this: 1, 2, 3, 4, 5. All values will be around the mean, symmetric around the mean. So half of the values lie below mean and half above it. Half of the values lie
Below mean.
half below mean and half will lie above mean. So it's like ideal condition, we can say. Generally, it is not followed always, but if your data is following the something like this, then we can call it as a Gaussian distribution or normal distribution. Simple. Two words you need to remember over here: normal distribution or Gaussian distribution. Okay. Then if you want to calculate something for this, like a normal probability distribution for the Gaussian distribution, you can write a formula: function of x on mu comma sigma square. This mu is nothing but mean for that particular data. Sigma square is nothing but variance for it, right? And different formula is the 1 upon 2 pi sigma square e raised to x minus mu square 2 sigma square. Obviously, there is no need to remember this one. But if you want to find out the distribution in backend, it is using this formula. Everything is included over here. You can see function which is giving you the probability to lie in that particular region, right? Probability that that point will be there. Probability that this point will be here. How it is calculated? So it is considering the four measures, main 4 measures you can see here, right? What is there? Mean is there. Each value is there. Each value of x. Suppose 1000 data points are there. 1000 observations are there. So 1000 observations are taken into the consideration, right? X minus mu square, right? So this is how it is working. Value of the variable, mean of that particular range or particular column or data points, standard deviation for it and variance for it. Is it okay? We are not going to calculate anything. Okay. In practical implementation, you will see mean is directly calculated, median is directly calculated, but how it is calculated, that we need to understand. What we are trying to learn, how that model is calculating those things, or what is the difference between mean and median, when we can use a mean, when we can use the median. Okay, so that thing we need to understand. If you want to go in more depth, some empirical rules are there for the normal distribution. Okay, if you are considering your whole data as 100%, right, and how you have converted it into different regions. So this mu is nothing but mean of your data mean of your data. If, for example, it is like this, 1, 2, 3, 4, 5. Okay, what will be the mean for this? Mean will be 3 for this, right? Mean will be 3 for this, and values are like this: 1.5, like plus 1.5, 0, minus 1.5. Here it is a 4.5, then 6, then 7.5. So its difference for each value is 1.5. That is nothing but standard deviation. That is nothing but standard deviation. This mu minus sigma. Sigma stands for standard deviation.
Variance.
1 sigma. No, standard deviation, is it?
Variance.
No, variance is a sigma square. Variance is a
Standard
sigma square.
deviation.
Variance is equal to sigma square. Standard deviation is equal to sigma. Any doubt in this?
Okay, sir.
Any doubt, Saranya?
No, sir. Yes, sir. Got it.
How I am remembering this? Yes coming first. After that, V is coming, right? So who is bigger?
Yes, sir.
Who is bigger? V is bigger, right? Na?
P is
In
bigger.
alphabets. In alphabet, V is bigger. So the same way I am remembering this. V is equal to V is bigger. So S square will be a V.
Okay,
Is it
sir.
okay?
Yes, sir.
So
Yes.
standard deviation, sigma. So just a difference of a standard deviation. 1 standard deviation, 2 standard deviation, 3 standard deviation. Till what we need to go? Till 3. 3 on left side, 3 on right side. So it will be symmetric about the mean. Is it okay?
Okay, sir.
Yes.
The margin that you are going on a left side, same margin should be on a right side. If I am going with a 1 standard deviation on left side, 1 standard deviation on right side. Okay, so I will call it as a 1 standard deviation. After that, 2 standard deviation, that is plus 2 sigma minus 2 sigma. 3 standard deviation plus 3 sigma minus 3 sigma. So this is just a boundaries for it. Anything that is below this, anything that is below this, anything that is above this will be outlier. Okay, so this rule enables us to check for the outlier and very helpful when determine the normality of any distribution. So if you are plotting this and if your graph is like this symmetric, you can say your data is following a normal distribution. Almost all the data lies within a 3 standard deviation. 3 standard deviation, that means 3 standard deviation on a left side, 3 standard deviation on a right side. But what is its margin? So for 1 standard deviation, how much data it should have? 68.27%. Generally, it is 68, 95, 97 rule. Sorry, 68, 95, 99.7 rule. If 68% data is lying in 1 standard deviation, 1 sigma, if your 95% of data points are lying in a 2 standard deviation and near about 99.7, so approximately 100% data is lying in a 3 standard deviation, we can say your data is following a normal distribution, and you can determine the normality of your distribution, and anything that is outside this range, you can say it is an outlier. Okay. Obviously, there is no need to remember these things, but if somebody asking you the like rules for the normal standard deviation, 68, 95, 99, that's sufficient. Okay.
Okay, sir.
Then it comes to the standard normal distribution. Till now we have just covered the normal distribution, right? So there may be it may be like this. 3 is a
Mean.
mean,
Mean.
then 2, 1. In this case, I'm taking 1 as a
1.
standard deviation.
Standard.
Here it will be 4 and 5. So these values are given over here. So whatever we are representing with values, that will be normal distribution. If we are taken into the account standard deviation, what I am taking into the account? Standard deviation, then it will be standard normal distribution. Instead of this, if it is like this, 0, then something like this, -1, -2, 1, 2, 3. So these are not values. These are the standard deviation values. These are not actual data points. These are actual data points. These are the values of a standard deviation. Is it okay? In standard deviation, at center, you will find mean as a 0 always. In standard deviation, you will find mean is always 0. And according to that, values are adjusted. Okay. So standard normal distribution is a special case of a normal distribution. Standard normal distribution is special case of a normal distribution when mu is equal to 0,
Zero.
mean is 0, and sigma is equal to 1. Sigma is equal to 1, minus 1 plus 1. Okay. If you are moving on that, like 2 sigma, that will be minus 2, minus 3, plus 2, plus 3. Okay. So for any normal distribution, we can convert it into the standard normal distribution by using the formula z is equal to x minus mu divided by sigma. So x is a value of variable. 1 minus what is the mean for this?
3.
Yes,
3.
3, right now. So what will be the value? 1 minus 3 divided by standard deviation. Whatever standard deviation is there, suppose 1 is there. So it will be minus 2. Again, 2 minus 3 divided by 1. It will be minus
1.
1. Then 3 minus 3 divided by 1 is equal to 0. So it is converted into the standard normal distribution. So these are with the variables mu plus sigma, like that. Mu is a 3 over here. So 4, 2, these values are there. And these values are converted into the 0, minus 1, plus 1 in a standard normal distribution. So standard normal distribution is a case of a normal distribution where mu is always 0 and sigma is always 1. Okay.
Yes, sir.
Then in order to like check the normal distribution, we can plot a different charts as well. We can plot a histogram, okay, where it will give you the some curves and areas like this, some densities. So these are the just densities of your values, different densities for your values. And this curve is giving you the probability to lie on that, or like what is the like nature of that curve. There is something called as the KDE plot. So we can plot this. Obviously, we are going to plot this with the help of Seaborn. In Seaborn, there is function which is called as the KDE plot, which is giving you this bell-shaped curve. If you want to plot this bell-shaped curve, you can use this KDE plot over there. Then there is something called as the QQ plot, quantile plot, which is like plotted with help of libraries. Stats model is there. So stats model is used in order to plot this quantile, where it is plotting one reference line as 45 degree and data points are plotted like this. If it is crossing something, like some points are below that line, some points are above that line, we can say it's following the normal distribution. But if it is lying above only, if data points are below only, then there is some skewness, there is some distortion. That conclusion we can give. So these are some visuals, those we can use in order to check the normality of our data. Okay, we will implement this. We will implement QQ plot. We will implement KDE plot. Histogram we will use in a data visualization in future lectures. But for stat, we will go with a KDE and QQ plot. Right. So these things we need to understand first. Then there is something called as the correlation. We need to understand the concept that is called as the correlation now. So it's just giving you the like measure of linear association between two continuous variables. What is the relationship between two variables? Why we need to understand this? Continuous variable we are talking about right now. We are talking about a continuous variable. That means data is a continuous. Suppose salary is there. Suppose price is there. Okay. Suppose demand is there. Suppose experience is there, right? If different variables are there. So there should be some relationship. Suppose on x-axis you are having something. I am having experience values. 1 year, 2 year, 3 year, 4 year. On y-axis, what you are having? You are having salary values, right? And if you are plotting this for 1,000% you are having a data. So it is giving some line like this with increase in experience, salary, increases. So there is some relationship. We can say it's a positive relationship, right? It's a positive relationship or positive association between two continuous variables. What are the variables? Experience and salary. If you are plotting a graph like this, suppose on x-axis you are having price, on y-axis you are having demand. If price is more, demand is less. If price is less, demand is more. So graph nature will be like this, is it?
Yes, sir.
Opposite
Yes,
one. So it's a negative association or negative relationship. But there is some relationship. If somebody want to find out from it some insights, if somebody wants insights, okay, what if price is this, what is the like demand? So they can give some association between that. But if some graph is coming like this, there is some variable A, there is some variable B, and it's like this. Okay, A is increasing, B is not increasing, B is a constant. So there is no relationship. So just tell me whether we should have a relationship or there is no relationship. There should be no relationship. If we want some insights for our output, what should be there? Which type of relationship you will like? What type of relationship you want? Positive, negative, or no
Positive.
relationship?
Positive
Positive.
relationship.
And what about negative?
sometimes negative also.
Sometime negative also, right now? Depend. Depend. But there should be, it depend. It may be positive, it may be negative, but there should be some relationship,
Yes.
whether it is positive or negative. That's why its value will lie in the range of -1 to +1. -1 that is a highly negative relationship, +1 that is a highly
Positive.
positive relationship. So it will be just like a number line: -1, 0, +1, -1, 0, +1. If they are having negative relationship, -1 is there. Positive relationship, +1 is there. If 0 is coming, after calculating the coefficient of relationship, coefficient of Pearson coefficient of relationship, if it is coming as a 0, that means there is a no relationship. 0.30, that is a like less correlation between two variables. What we are expecting, the value of R, there is a coefficient of correlation, coefficient of Pearson correlation should lie below -0.75. Please remember this word, below -0.75 or above +0.75. Is it okay? So something like below this and something like above this. Is it okay? 0.75 is the like threshold for us. If after calculating the Pearson coefficient of correlation, we are not going to calculate it analytically, directly you will get the values. But what is the acceptance criteria? It should be below -0.75 and above +0.75. There is no thumb rule, but what is the meaning of -0.75? It is a highly negative correlation. What is the meaning of +0.80? It's a highly positive correlation. Is it okay?
Yes, sir.
How it is calculated? It's a relationship between X and Y. What is the X? Input. Experience my input, X. Salary is my output. What is the relationship between input and output? That I am calculating over here. And it is calculated with each value, Xi, summation of Xi. If 100 variables are there, 100 data points are there, then 100 different summations will be there. Here 100, in Y also 100, multiplication of each against square root of the same. Okay, X is a variable sample, Y variable sample, mean of X values, mean of Y values, that way. Is it clear?
Yes, sir.
Yes, sir.
Okay. Obviously, we are not going to calculate anything, but what you need to understand from this, there should be some correlationship. There should be some correlation between the input and output. What I am talking about?
The relationship between two.
Input and output. Huh? Input and output only. Input and output, X and Y. There should be some relationship. It may be positive, it may be negative. And what is the range? -1 to
0.
+1. Okay. When it comes to skewness and kurtosis, what we talked till now, your data, your graph is symmetric about a mean. Your graph is symmetric about a mean, but it may be distorted on left side. It may be distorted on right side as well. It may be distorted or like vertical distortion may be there. It may form a peak. It may be flat. Different things may be there, right? Now, this is ideal one. This is ideal one, but different scenarios may be there. So those are defined with the help of skewness and kurtosis. So what is mean by skewness? There is a degree of asymmetry. Degree of asymmetry. That is, it means it's shifted somewhere. On left side, less data is there. On right side, like most of the curve lying on the right side. Left skewed like this. Again, bigness in the data distribution, degree to which data values are concentrated around mean. Suppose mean is there, 3 is there, and most of the values are around the 3. We release values away from the 3. In this case, we release values around the 3, and most of the values are away from the 3. Okay. In skewness, there are two types, like right skewed data. So we can say it's a horizontal distortion. Skewness is nothing but horizontal distortion. This is skewness, this is skewness. And this thickness, that is a kurtosis. Kurtosis is vertical distortion. Your bell-shaped curve is distorted vertically. Either around mean most of the values are there, or like suppose 1000 data points you are having, and out of 1000, 900 around the mean. Only 100 points are shifted. What will be in this case? 100 around the mean, only 900 are away from mean. Is it okay? Hello?
Yes, sir.
Are you getting things?
Yes, sir.
Okay. We are not calculate anything, like no analytical calculation will be there. Just we are trying to understand the concept, what concepts are there. If it is shifted on the left side, we can say it's a negatively shifted. Skewness is calculated by the formula mean minus mode divided by standard deviation. Okay. And types for the kurtosis are mesokurtic, leptokurtic, and platykurtic. Mesokurtic is that is ideal one. Okay. Before that, we will focus on this one. What is this? Positively skewed data, right skewed data. On one side, you can see median will be always center. Median is at always center. Mean and mode will deviate. Again, here median is there. Mode on this side, mean and on left side, because the side on which data is more, this side data is more, right now. That's why mean is shifted. We have observed this 1, 2, 3, 4, 5, and 100. I have taken right now. So 19 is a mean in this case, which is shifted right now. And what was the median? 3.5 was the median, right? Again, in this case also, it will be shifted to the left side. If I'm using 100, minus 100 like that. So mean is more influenced due to distortion in data, or due to outlier, which is shifted more, mean is shifted more, right? Is it okay?
Yes, sir.
Median will be always at the center. So most of the time we are going with a median. Median is a less influenced by outlier. Median is less influenced by outlier. Okay. So you need to consider this thing. Again, in case of kurtosis, mesokurtic, that is a moderate. If mesokurtic value is a 3, you can say it's a this green one. This green one curve is like symmetric around the mean, and like particular range of values are around the mean. If your data is concentrated around the mean only, then it's a leptokurtic, and if it is flattened about a mean, then it's a platykurtic. So it's a vertical distortion is there. Vertical distortion in data is known as kurtosis. So two types of distortion are there, skewness and kurtosis. If you are calculating its value directly, if it is like lower than 3, then it's a platykurtic. If it is more than 3, it's a leptokurtic. Okay, there is no need to like go with these values. Simply you can say your data is distorted vertically, having a kurtosis like that. So till now, like till this point, what was there? descriptive statistics over there, right? Descriptive statistics. You can observe.
Sir, these terms we will use like mesokurtic, platykurtic. We will use further.
No, not like that. We will not define it's the mesokurtic or it's the platykurtic or leptokurtic.
Okay.
Simply, we will say data is having kurtosis.
Okay.
Yeah. So these things are where there discrete continuous goodness to fit normality test or homostaticity. That means it is not following that particular range. Okay. So it's not about it's not symmetric about mean. So this all these things we related to descriptive statistics. Next point is related to inferential statistics. So that we need to understand now. What is this inferential statistics? What is it meaning? In inferential statistics, what we are drawing? We are drawing some conclusion, right? We are drawing some inference based on the population or based on the sample data about a population. Based on some sample, you are saying something related to population. So it's a procedure for the deciding between two possible statements about a population. If I'm saying average age of suppose average salary is equal to 50K. So it may be 50K or not 50K will be a second statement. Average salary is 50K and second statement would be not 50K. One will be a true always, right now? At least one will be a true. So deciding between two possible statements about a population. So that is a testing of a hypothesis. Hypothesis is nothing but some assumption. You are like assuming something and you are trying to prove it. Yes. Just like a guilty, not guilty that way. In court, what we are like suggesting person guilty or not. But that is just an assumption first. After some test, after going through the procedure, you are deciding whether that person is guilty or not. So what we need to do, we need to perform some test, and based on that test, you are giving your conclusion, right? So what will be the procedure for testing hypothesis? We need to formulate a hypothesis, collecting a data. Hypothesis, collecting a data, whatever data you are having. Then you need to choose a level of significance. Okay, level of a significance. That means there is some critical value for each test. Generally, we are going with that p value. Determine the p value or like level of significance, which is generally 0.05. What is like accepted value? 0.05. Like 5% rejection may be there like that. Calculating the test statistics. Now you have what is meant by statistic. The variable that is related to sample data, that we call it as a statistic. And after that, we are going for the making a decision or drawing a conclusion or drawing an inference about your data. So by the end of this like session, in upcoming 2 sessions, you will get everything, right? What is this testing? What is mean by hypothesis testing? What type of tests are there? How we can perform a t-test? How we can perform an ANOVA test? What are the conclusion we are making? Sorry, what are the claims we are making and how we are trying to prove it based on the null hypothesis and alternate hypothesis. So in a statistic, there are 2 types of hypothesis. How many types of hypothesis are there? 2 types of hypothesis are there. The null hypothesis is a prediction of no relationship between the variables we are interested in and denoted by H naught or HO. Okay, H naught. And alternate hypothesis is a prediction of relationship between the variables we are interested in. So these are the contrary to each other. Okay, contrary to each other. If I am like taking example of mean is equal to 50K. Average salary is 50K. What will be alternate? What will be alternate? Not 50K. But one or other will be a true always. Either it will be a 50K or not 50K. If I am assuming the average salary of India's people is a 50K, and that I am formulating for a null hypothesis. Okay. If my test is giving something like that, I will go with a null hypothesis. Otherwise, I will go with alternate hypothesis, but there should be some criteria. So there is no need to go with all these definitions and all. What you need to just understand level of significance. What is the level of significance and what value we are generally using for it. So the significance level is a value that researcher or whatever like analyst is there sets in the advance as a threshold for the statistical significance, denoted by alpha. How we are denoting it? With the letter alpha. The level of significance typically set to 0.05. What is the level of significance value? Always. What is the level of significance value? 0.05. Sometimes it's 0.01, but researchers, like most of the time I have also used this value 0.05, which means that researcher is willing to accept 5% chance of making a type 1 error. After some time I will explain, like in upcoming session I will explain what is a type 1 error. There is other type of error is always. Type 2 error is also there, right? As of now, just try to understand this alpha or p value, level of significance. We call it as alpha or p value. If this p value, after performing a t-test, I'm performing a t-test, I'm calling a t-test, and it is performed on some data. If this, my test is giving p greater than or equal to 0.05, which is true, null hypothesis is a true. I will go with the null hypothesis. If p value is less than 0.05, I will go with the alternate hypothesis. If my significance value or critical value is greater than 0.05 given by the test, then I will go with the null hypothesis. If p value is coming as a less than 0.05, suppose p is equal to 0.001, then we will go with the alternate. If p value is equal to 2.3, we will go with the null hypothesis. That's all. There is no need to like go in a depth, or like if you try to understand the by definition wise, there will be like a lot of confusion. As of now, just try to understand the level of significance or this probability value. If your test is giving you the value of a p as a greater than or equal to 0.05, you will use null hypothesis statement. Whatever you have assumed in a null hypothesis, suppose salary is 50k, then that will be true. Otherwise, second will be a true. Okay. So different tests are there to use this. P value is a probability of obtaining a test statistic. What is the probability? And those are used in hypothesis testing to help decide whether to reject a null hypothesis or not. Okay. So there is no need to go with this statement. Smaller the p value, most likely you will reject a null hypothesis. You will reject a null hypothesis means what you will use? Smaller p value. You will go with the alternate. So simply just remember this: p greater than 0.05. P greater than 0.05. Yes. Null. P less than 0.05. Alternate. This is the summary for this. Okay. So this is how you need to remember this. P value is greater than alpha. P value is greater than alpha. What is alpha? 0.05. And what p value? Test statistic. Your test is giving this value. And this alpha you have already settled. You have set this value 0.05. So it's less than or equal to level of significance. Then null hypothesis is rejected. And alternate hypothesis is accepted for making some decision, right? So these are some things. Those are related to the inferential statistic part. Next session is for like implementation of these things. What is mean? How we can find out the mean, median, mode. Then there is something called as the dispersion. Like we have seen the standard deviation square, that is a variance, how we can calculate the skewness in data, kurtosis. Then we have seen the KDE plot, we have seen the QQ plot, then Z value in order to find out the outliers. What we can say, Z value or Z value, Z score, right now? Z score we have calculated. Z is equal to x minus mu divided by sigma, this way. Again, outliers, how to detect the outliers, how we can calculate the IQR, that is what is Q1, what is Q3, how to calculate those values, and how those will be helpful in order to find out the outliers, that we will cover in a tomorrow's session, actual implementation for it. Is it okay, Obya, Saranya, Prema?
Yes, yes,
Sir, all this concept will be like seeing in real time
Practically with the help of Python,
with the help of Python.
Jupyter Notebook.
Okay, sir.
But there,
So
it will be
just to
used as
understand the concept will be enough, no need of calculation.
yeah, no need of calculation. Like suppose 1, 2, 3, 4, 5 is there, right now? 1, 2, 3, 4, 5 is there, and we are calculating mean like 1 plus 2 plus 3 plus 4 plus 5 or 15 divided by 5. So this is our calculation. But in actual practice, I will use like this np dot mean only, np dot mean of a date, and this is equal to t. So it will directly give me the value of 3.
That means you will
So that
have
implementation
functions for everything, sir.
Sorry.
For,
For variance.
for every calculation, we will be having functions or
np dot var, np dot std, np dot skewness. Every function is there. All functions are there that we will see tomorrow. Why I explain all these theoretical part? Because if I explain with the help of function, what do you will understand now?
yes, yes, sir.
Yes, sir.
That's why I explain this theoretical concept first.
Next, we should know the concept.
Yeah, just to understand
is
the
what?
concept. Yeah,
What is what? Yes, sir.
yeah, correct.
Okay, sir.
Okay, so that's all for today. Thank you. If you have any doubt, please ask. I have shared the PPT already, right?
Yes, sir.
Yes, sir.